All right, welcome. Today we are going to dive deep into a 12-mark GCSE chemistry question. You know, the kind of question that can seriously boost your grade. We're not just going to answer it, we're going to pull it apart like an examiner would, so you can see exactly where every single one of those marks is hiding.
So this is the big question, isn't it? It's one thing to know the science, but it's another thing entirely to present it in a way that just ticks every single box for the person marking your paper. And mastering that skill, well, that's exactly what we're here to do today.
So here's our game plan for this explainer. First, we'll introduce the big 12-mark question. Then we'll break it down into 3 manageable chunks. And we'll finish up with a perfect, full-mark answer sheet that you can use for your revision. Sound good? Okay, let's jump in.
Right, first things first, let's get a good look at the challenge we're facing. This isn't just one question, really. It's more like a mini-test with a series of connected parts that cover a huge range of your chemistry knowledge.
And here it is, question 09 from an AQA higher tier paper, and it's all about methanol. Now think about this for a second. 12 marks. That's a huge chunk of your final grade, potentially over 10% of the whole paper, all in this one place. So you can see why nailing this is such a big deal.
Let's ease into it. We'll start with the first 2 parts of the question. These are quick, 1-mark questions, kind of like a warm-up. They're pretty straightforward, but you've got to be precise to bag these early marks.
Okay, question 9.1. The key words to lock onto here are catalyst and in the body. This is a bit of a crossover with biology, isn't it? So what do we call a biological catalyst?
And the answer is enzyme. That's it. 1 word, 1 mark. The examiner just wants to see that single precise term. No need to overthink it. Bam! First mark is in the bag.
All right, now for a quick calculation. The secret here is all in the balanced equation. See those big numbers out front? They tell you the ratio. We have 1 mole of carbon monoxide reacting with 2 moles of hydrogen. That 1-to-2 ratio is everything.
So, if the question gives us 4.0 times 10 to the 3 moles of hydrogen, we just need half that amount of carbon monoxide, right? Half of 4.0 is 2.0, so the answer is 2.0 times 10 to the 3 moles. A simple bit of ratio work, and that's our second mark secured.
Okay, 2 marks down. Now we're getting into the real heart of the question. We're talking reversible reactions, we're talking Le Chatelier's principle. This is where explaining your thinking clearly is absolutely vital if you want to pick up these bigger marks.
Okay, a 2-marker on temperature. The question tells us the forward reaction is exothermic. It gives out heat. We have to explain what happens to the yield if we crank up the temperature. And notice that keyword, explain. That means we need to say what happens and then say why it happens. Let's peek into the examiner's playbook here. To get both marks, you need 2 things. For point 1, you get a mark for just stating you get a smaller yield. For point 2, you get the second mark for explaining why, because the equilibrium shifts to favor the endothermic reaction. And check out that note at the bottom. The examiner will completely ignore anything you write about the rate of reaction, so stay focused on yield.
And here it is, the big one, 4 marks. We need to explain the effect of pressure on both yield and rate. This needs a really detailed, well-structured answer. We've got to explain why the yield goes up and why the rate goes up. There are 2 marks on offer for each part.
So here are the 4 points you need to hit for the full 4 marks. Let's break it down. For yield, first you say the equilibrium moves to the product side. Second, you explain why, because there are fewer moles of gas on that side. That's 2 marks right there. Now for rate. Third, you have to state there are more frequent collisions. And fourth, you explain why, because the gas molecules are closer together. Each of those points is worth a mark. That's how you build a perfect 4-mark answer. We are on the home stretch now. This last part of question 9 is all about the catalyst. These questions test those really fundamental ideas about what catalysts actually do in a chemical reaction. Here we go, another 2-mark explain question. And it's a real classic. This is the definition you should know inside and out, but to get full marks, the examiner is looking for 2 very specific phrases.
And this shows it perfectly. To get both marks, you need both parts. First, a catalyst provides a different reaction pathway. That's your first mark. Second, you have to say that this pathway has a lower activation energy. That's your second mark. Just saying it lowers activation energy on its own might only get you 1. Precision is everything.
Whoa, pay very close attention to this one. It's only 1 mark, but look at that instruction in the brackets. Do not give answers in terms of increasing the rate of reaction. They're specifically telling you not to use the science definition we just gave. They're asking for the industrial reason. This is a classic exam trap.
So what are they looking for? It all comes down to efficiency and money. The mark scheme will accept answers like less energy is needed. It reduces the temperature required. Or, even more simply, it reduces costs. Because the catalyst lets the reaction work at a lower temperature, the factory saves a ton of money on its energy bills. That's the real-world industrial advantage.
And for the final mark, question 9.7. This is a pure test of your understanding of what catalysts do and, just as importantly, what they don't do. So, what effect do they have on the final equilibrium position?
And the answer couldn't be simpler. No effect, or no change. You see, a catalyst speeds up the forward reaction and the reverse reaction by exactly the same amount. It helps you get to equilibrium much, much faster, but it doesn't actually change where that equilibrium is. You don't get any more methanol in the end. It's a simple fact that grabs you that final crucial mark.
And that's it. We've deconstructed all 12 marks. So now, let's pull everything together into one simple summary sheet. Think of this as your blueprint for a perfect answer.
And here it is, your full mark answer sheet in one place. Let's do a super quick run through. 9.1, enzyme. 9.3, smaller yield because it favors the endothermic reaction. 9.4, remember it's 2 parts. For yield, it's about fewer moles. For rate, it's about more frequent collisions. 9.5, the classic 2-parter, alternative pathway, lower activation energy. 9.6, the industrial reason is all about reducing costs. And finally, 9.7, no effect on yield. Honestly, this slide is your revision gold dust.
And really, that's what this all boils down to. You can know your chemistry inside and out, but to scoop up every single mark on the table, you have to learn to think like an examiner. Know the key phrases they're looking for, structure your answers clearly, and that is how you turn good answers into perfect, full-mark responses.